Hi, welcome to the Potential of All Potentialities. This is the Remembering the Future segment on what is the visible universe made of. Hopefully, it will get you excited about coming out to see one of my live events at one of the various conferences and expos where I appear. You can always find out by going to xsquaredradio.com and clicking on the Events tab on the left-hand side. Easy to do. So let's talk a little bit about the universe. What is it made of? Well, it's made up of protons and electrons. It arranges itself in particles we call atoms. Atoms are made up of these protons and neutrons. Neutrons are formed by combining a proton and an electron, like a +1 and a -1 equals 0. That's a neutron. So these protons and neutrons collect each other together, nuclei, which form atoms by atomic number. The electrons are on the outside around it. I'll explain a little bit more about that in a minute, but I want to talk about the proton itself, because the proton is kind of a mystery. We have splattered these little beggars apart with CERN billions of times, and we pretty much know the menu of particles it takes to make up a proton. But for all that knowledge, for all the collection of all these menus, the frequencies, the energies that it takes to make a proton, we still cannot form a single proton. We don't know how to make one. We can take them apart, but we can't put them together. One of the things that we have learned about them is that they're put together with various energies in resonance with one another. They're different frequencies, different wavelengths, and they kind of form a holographic resonance. That is to say, when they resonate with each other, they come together as a proton. If they don't resonate, then they just end up as chaotic energy in the universe. When they come together, it's a little bit like the principle of when we make images. We make images using color dots. We arrange them in CMYK, which is cyan, magenta, yellow, and black, or RGB, which is red, green, and blue. And when we combine all these colors together, we get white. When we separate them apart, we get the different wavelengths, and we can arrange them in what's called a stochastic pattern to create an image. When we separate them apart, they make color. When we combine them, they make different colors. And the point is that we can make an image like this flower that we see. Now, this flower, if you look at it, you can see all the components. You can see the petals, you can see the iris, you can see the pistil, you can see all the detail of this flower. But if we were to zoom in really deep on this picture, what you would really see are dots. You would see these cyan, magenta, yellow, and black dots arranged, set close to one another in a certain pattern. This is, of course, we're blowing this all the way up to thousandths of an inch so that you can see what's making it up. It's the same thing as a proton. Same thing as a proton. But the interesting thing about that picture of that flower that I showed you, it's a little pale. It's because a sampling of these dots has been removed. Not all one color, but some of all the colors, so that you get a kind of more pale image of it. If we were to put all that energy back in, all those frequencies back in, you'd get a much more rich, full color of the flower, like this. You see, all the yellow is there, all the red is there, all the green is there. Now you can really see the detail of the flower. This is holographic theory when it comes to resonating frequencies together to make matter.